Hello friends, welcome to this new video. In this video we discuss integration of some improper integrals. Will from the improper integral is let us integrate or test the convergence of integration 0 to 1 dx divided by under root of 1 minus x cube. We know that this function has infinite discontinuity at x is equal to 1. So, if we consider f of x is equal to 1 divided by under root of 1 minus x cube, we write this function as 1 divided by under root of 1 minus x as a one factor and other factor is 1 plus x square. Then this is equal to, or we write it as 1 divided by under root of 1 minus x whole raised to 1 by 2 and 1 plus x square whole raised to 1 by 2. Then the integration 0 to 1 divided by under root of 1 minus x cube dx, this will be converted into integration 0 to 1 divided by 1 minus x whole raised to 1 by 2 and 1 plus x square whole raised to 1 by 2 into dx. If we separate this is integration 0 to 1 divided by 1 minus x whole raised to 1 by 2 and another one is 1 plus x square whole raised to 1 by 2 into dx. So, it is of the type f into g into dx. Then say the second integral, this term 1 divided by 1 plus x square, this term do not have any singularity for 0 and 1 and in between 0 and 1 for any value of 0 to 1. We get a maximum value of this function at x is equal to 1. So, this function is an bounded function. Since this function 1 divided by 1 plus x square whole raised to 1 by 2 is bounded in close interval 0 comma 1 say by capital M, then this is an upper bound. This is upper bound. We take it as an upper bound. Therefore, this integral 0 to 1 divided by under root of 1 minus x cube into dx, this will be less than equal to capital M is an upper bound, integration 0 to 1 divided by 1 minus x whole raised to 1 by 2. Now consider this integration, compare this integration with a to b 1 divided by 1 x minus b minus x whole raised to n into dx, and we know that this integration converges for n less than 1 and diverges for n greater than equal to 1. Here you can check that the value of n equal to 1 by 2. Therefore, by this useful integration we can say that this integration is convergent, since integration 0 to 1 divided by 1 minus x whole raised to 1 by 2 into dx is convergent. Now apply the comparison test. By comparison test, if we have two integral f of x less than equal to g of x, and if g of x is integration of g of x is a convergent, f of x is also convergent. This is a comparison test. Here this integral is a convergent integral and therefore this integration 0 to 1 divided by under root of 1 minus x cube into dx is convergent. So, here you can see that how we have applied the integration 1 divided by x minus a whole raised to n. Here we have taken integration of b minus x whole raised to n, since this integration has a infinite singularity at the right end of the bounds. Now let us see one more example. Suppose we would like to test the integrability of the function integration 0 to pi by 2 sin x divided by x raised to p into dx. This is my integration, and when we put x is equal to 0, this function has an infinite singularity. And we know that this is this integral, it is a proper, it is proper for p less than equal to 1. That means whenever p is equal to 0, we have integration of sin x is integrable. When p is less than 1, we have x into sin x. Again we can apply the product rule. If p is minus 2, we get x square into sin x. Again we can apply product rule, and it will be easily integrable. So it is a proper for p less than equal to 1, and it is improper for p greater than 1. Okay. Now if my f of x is equal to sin x divided by x raised to p, we write this as 1 divided by x raised to p minus 1 into sin x divided by x. Then we know that this sin x divided modulus value of sin x divided by x is less than equal to 1. So this is less than equal to 1 divided by x raised to p minus 1, and therefore integration 0 to pi by 2 sin x divided by x raised to p into dx will be less than equal to integration 0 to pi by 2 1 divided by x raised to p into dx, x raised to p minus 1 into dx. And again we can apply the theorem integration a to b dx divided by x minus a whole raised to n. It is a convergence for n less than 1. So by using this theorem, we can write it as x minus 0. Then 0 is the infinite discontinuity of this function. Therefore it is the integration 0 to pi by 2 1 divided by x raised to p minus 1 into dx is convergent for p minus 1 is less than 1. Adding 1 to both sides, p is less than 2. Okay. So therefore the integration 0 to pi by 2 sin x divided by x raised to p into dx is convergent for p greater than for p less than equal to 1, and we have seen that it is a convergence for p less than 2. So it is a less than 2 and diverges for p greater than equal to 2. So this is about, here you can see, if we take this this is about the useful comparison test. Thank you for watching the video.